It's me, Mr. Allen. How's it going, guys? So I am going to be doing our trig review to hopefully prepare you guys for your exam tomorrow. So this one here, we've done lots of these questions in class already, but let me just go over them really quickly. Be a good review as well. All right, so let's move my face around here. Let's put my face up here. All right. So these first couple of questions here, we've done these questions before. I'm just going to quickly cruise through them, just going to refresh our memory of what the reference angle is, because that's one of the key here. So we want to determine what the reference angle is. All right, so we're going to start by drawing our initial arm, and then I'm going to draw an angle approximately 35 degrees from that. So there's my standard position angle there, so that's 35 degrees. Maybe I should erase that and actually put in what the actual angle is here. Okay, so that's going to be 35 degrees. Okay, so that's me drawing the terminal arm, the initial arm, and labeling the angle. So that's kind of what I expect. It looks like we land in quadrant 1, and the reference angle, measure from the terminal arm back down to the nearest x-axis. That's just measuring the same angle, so that's just going to be 35 degrees as well. There we go. This one here is a little bit different because it goes into a different quadrant. So we start here, and then we start measuring an angle until we get to about 165. That looks about right. I'll label off 165 degrees for that angle. And then when I measure my terminal arm, from my terminal arm to the nearest x-axis, we're going to measure down here. So that's where the reference angle is going to be. I'll just label that over here too. All right. Then we do a little bit of math there, and I think we get about 15 degrees for that one. And we land in quadrant 2 this time. All right, and then my last one here, 216. So I put my initial arm here. I draw around past 180, somewhere down here. There's 216 degrees. That's quadrant 3. Let me just change my color here. Quadrant 3. And it looks like my reference angle, measuring from here back to the nearest x-axis. Okay. Doesn't matter, it's always going to be a positive angle anyway. So if you mess up your math and you subtract the wrong way, if you get like negative 36 degrees rather than just positive 36, just ignore the negative. All right, the negative is not needed for the reference angle. It's always going to be a positive number. And the reference angle, just remember, it's always going to be less than 90 degrees. So if you get something that's bigger than 90 degrees, then you did something wrong. All right, so determine the exact value of these angles. Now, again, nothing really stops you from just punching one of these angles up into your calculator. I'm just going to load up the calculator for this question for later. But if I do, so I notice I'll get -1 here. Now, to do this question, you have to kind of imagine, I'm going to do it for this one here first, is that if you were to draw this, I'm going to put it into this quadrant down here, you would be able to draw a triangle in this quadrant, just like before, going right to the reference angle down to the nearest x-axis. You would be able to draw a triangle here with a reference angle of 30 degrees, if that's a 210 degree angle. Then you would pull out one of your formula sheets, which I don't have on me, and then you would find out that the formula sheet has this triangle on it. So I'm allowed to just jam it in there. It's all about similar triangles anyway. It doesn't matter how big or small it is. As long as it fits with the proper angles, we're good. And what's across from the 30 degrees is going to be the 1. But because it's going down, we've got to put a little -1 there. And then what's adjacent to the 30 degrees, because it's going backwards, it's also negative, is root 3. And the hypotenuse is 2 in this picture. Like I said, it can be scaled up or down no matter what you want. In this case, the hypotenuse is be 2, but sometimes the hypotenuse is 1. And then, from there, we just write out our numbers. What do we have? So tan is going to be opposite. I can't see it up here, but it's above my head. Opposite over adjacent. Well, it's just 2 negatives, so that turns out to be positive root 1/3. There we go. So we have the calculator for that reason. All right, so we can just punch in like cos 180 or something. We can type it in, or we can type in tan 210. So make sure your calculator's in the right mode. And you get that number, but that number is the same as 1 over the square root of 3. So they're both the same. So at least we know we did something right. Now, the reason this one over here is -1, so we have to kind of imagine, I'll put a green here, sorry. We have to imagine that there's a 180 degree here. But what I'm going to do is I'm just going to draw it just a little bit off 180 degrees. Just enough so I can kind of draw a triangle in here. That goes down towards the x-axis, goes over. Where this degree in here is 0 degrees. So the lines, so like they're not actually here, but they're right on top of each other. And this opposite side here, because they're like supposed to be right on top of each other, this is going to be 0. And then let's just imagine the hypotenuse is 2 again. And because the lines are right on top of each other and they're going straight to that same point at the very end there, this just happens to be -2. Right? If I made the hypotenuse 5, that would be -5. If I made a hypotenuse 1, it'd be -1. Then when I do cosine, I'm going to get -2 adjacent over hypotenuse, which turns into -1. Okay? Even though it's not really a triangle, it's just a flat line, we can kind of treat it as if it's a triangle, just like we did these previous questions. Okay, so 315 would be somewhere right about here. Let's draw that out. 315 degrees. If I were to draw out a triangle here, I should be able to draw a 45 degree, 45 as well. It's an isosceles triangle in this area here. Because it's going down, so I go to my formula sheet and I see there's a √2 and a √2. So I'll say that this goes down √2 and this one goes over √2 and the hypotenuse is 2. It's sine, so sine is going to be opposite over hypotenuse. So opposite over hypotenuse. And then you can double check. Should be -0.707. Is that right? Yeah, -0.707. All right, so let's keep on going. Hopefully, the alarm's not going to go off anytime soon. It's a bit late right now. So a -4 and 5 land somewhere right about there in this quadrant. So if I were to draw a terminal arm going through that point, there's the angle that I would have. I don't know what that is. I might be asked, like, how can I find that angle? Well, just like the ones above it, or any of the questions we usually do, I should be able to draw a triangle here. And that triangle is going to help me figure this angle out. That's going to be 90 degrees there. And because this point up here is -4, 5, I know the lengths of this triangle, because that's to get there, I have to go back 4 and up 5. Okay? Just because, why not? Most of the time we just complete these things anyway, so I'm just going to find the hypotenuse by going a squared plus b squared is equal to 41. However, that's equal to c squared. So c is the root of 41. They wanted its exact value as well, so we're going to leave it as a radical. So that's going to be the root of 41 there. All right? And then you say, okay, now I'm going to go try to find the angle. So what would I do to find the angle? Well, I'd write out sine. Okay, I don't know what theta is yet, but I can write out the ratio that would go with sine. So I can say like 5 over, oh, we needed that root 41. There we go. And then we take the sine inverse, find the reference angle, do all that stuff. All right? I'm not doing that because it doesn't want me to do that. It just wants me to write this ratio out. But imagine I don't want to be a sinner. All right? Or my sine in my calculator is broken, so maybe I'll use cosine instead. All right, how would I do that? So I'll go adjacent over hypotenuse. Okay, there I needed that root 41 again. Oh, but imagine I'm typing in my calculator, oh, my cosine button's broken. So how would I do this now? Well, maybe I can use tan. And tan would be 5 opposite over adjacent. You don't have to write with the negative on the bottom. It's not wrong, but it just doesn't look nice. There you go. So I can use any one of those, take the inverse of them, find the reference angle, and then continue on with the question. All right? I could. I don't want to. But I'm not, yeah. This is a very similar question. It just wants you to find the other two. So right now we have sine. Well, maybe for some reason my sine on my calculator is broken and I can't use it. So maybe I'll just have to draw it out. It's in the second quadrant, so somewhere in this quadrant, there's an angle. And they've done some kind of math already where they drew a triangle and they determined that from this ratio, because remember this is going to be opposite over hypotenuse, that the opposite is 15 and the hypotenuse is, oops. That happens once in a while because I hit the button, my weird button, or thingamajigger here. The hypotenuse is 17. Remember, the hypotenuse is always positive, so if I had a choice, like it was negative, the legs will be negative, but not the hypotenuse. Okay. But see, maybe my sine button's broken. I'm like, okay, how do I solve this question? Maybe I can use cosine. Maybe that button works. So I have the hypotenuse, 17, but I need the adjacent. So I'm going to do some math here. Remember, this is the opposite of the Pythagorean theorem. We have the hypotenuse, but we're looking for like one of the legs. So let's just call it A for now. Right? So I get 17 squared minus A squared. I'm not going to show all that, but I'm pretty sure you could figure that one out. Get 64. A is going to be 8. But because it's going backwards, it's technically negative 8. That's very important. All right? And we got plus or minus when you take the square root of things. All right. So now I know it's negative 8. Put a little negative 8 there. And then I can use the cos inverse. Blah, blah, blah. Maybe that doesn't work. So I'll use the tan instead. So I got an opposite with the negative on the top there. Negative 15 over 8. Cool. So I could, at that point, take the inverse, try to solve it. Perfect. All right, so let's go down here and say, let's say I've done that. I've done the inverse, or I haven't done the inverse yet, but I found the ratio. So I drew some kind of triangle. I did, like, in this case, adjacent over hypotenuse. And now I want to actually find the angle. So there's a few different steps here. So the first step, I don't know, maybe one of the first steps, doesn't matter which step you do first. I would probably either figure out where it is or figure out the reference angle. Both will work just fine as the starting point. So maybe I'll just find the reference angle, and to do that, you just take the inverse. That's why we were doing all that stuff before. So I can just take the cos inverse, 0.5877, 54 degrees. Okay, I'll just put it the nearest degree. That's a lot of zeros on that. 54 degrees. Okay, so now I have a reference angle. The problem is I don't know where the angle is in. Like these questions up here, this one specifies, oh, it's quadrant 2. This point lands in quadrant 2, right? But where does this land? It doesn't tell us. So because it doesn't tell us, we're going to have to use our cast rule or add sugar to coffee rule. Because this is positive, we have possibly two places it could be. It could be in the all quadrant, all are positive. It could be in this sugar quadrant, or that's where the sine is positive. It could be where cosine quadrant, or it could, oops, that's not the cosine quadrant. Let me move my head out that way. That's the tan quadrant. Just add sugar to coffee. So that's my tan coffee. And this is my cos quadrant. Right? So usually I just put the letters there, but I'll write out all the words up for that one. And because this is positive, I could put it into the first quadrant, so it could be in here, and I'll just draw about 54 degrees here. Okay. Or maybe it could be in, I'll use blue. Maybe it could be in this quadrant, because cos is also positive in that quadrant, so it could be down here somewhere. Now, the reason I knew this was 54 is because the reference angle was 54 degrees. So these both have a reference angle of 54 degrees. Okay, so remember, when you're in the first quadrant, the reference angle and the standard position angle, they just happen to be the same thing. So because I know that, one of my answers is 54 degrees. Now the other angle, this bigger one, remember I'm going to have to go, because that angle is pointing towards the 360 line, I've got to go 360 minus 54, and that's going to help me find my other angle. 360 minus 54, that's 306 degrees. Now remember, you can always verify these. And like, oh man, And did I do this correctly? Well, it's within my domain from 0 to 360, so that's good. But now I just want to make sure. If I go cos 54, that's pretty close to what it should be. Remember, it's rounded. And if I go cos 306, well, it's the same number, positive, yeah, looks good. If I put it in the wrong quadrant, we get like negative answers by accident. And then maybe I'll put a box around our answer here. There we go. All right, so we do the same thing here. I'm going to do the cos, or in this case, the sine inverse. Now remember, if you have, well, not if you have the option, if you want to find the reference angle, you ignore the negative. So even though it says negative root 3 over 2, I'm just going to go positive root 3. Now it's not going to work in the calculator. Over 2. Oh, 60 degrees. Perfect. All right, 60 degrees. All right. Now, because of the add sugar to coffee rule, add sugar to coffee rule, because sine is negative here, it's not going to be in the first quadrant, not going to be in the second quadrant. It's got to be in the third and the fourth quadrant. Because that's where sine is going to be negative. So that's 60 degrees, and I go up there. All right, and then I'll draw my other angle in there. I'm going to be in this quadrant down here. All right, so I got to find those two standard position angles, those bigger kind of spirals there. I know the reference angles for both of these are 60 degrees. That's 60 degrees. And I can do a little bit of simple little math. So this one here is pointing towards the 180 line. So that's 180 plus 60. So that's going to be 240 degrees. And this other one's going to be 360 minus 60, which is going to be 300 degrees. And then pull out your calculator, and you just make sure it ends up being the same thing as negative root 3 over 2. So root 3 over 2, don't remember what it is. Make sure that root 2 is not there. So that's 0.866. If I go negative that number, that's good. We want that. We want it to be negative. And then sine, what was the other one? 240. Perfect. Looking good. Put a little check mark beside them. I verified them. Make sure you actually verify them. Don't just put blind check marks there. Actually put them in your calculator and see if they're the same. I hate when people don't do that. Or say they did and they didn't. Okay. So this one here, we're just going to use our exact triangles, our triangle that we found on the formula sheet, because of the 60. And this angle up here is going to be 30 degrees. I can compare it to the other 60, 30 degree triangle that we have. So that 60, 30 degree triangle, there's a root 3 across from the 60, there's a 1 down here, and there's a 2. So I just have to think, how do I get from one to the other? Okay, so they gave us the hypotenuse. We're going to compare the hypotenuse. We're like, how do we get from a 2 to a 12? Well, I times it by 6. Oh. That just means I times everything by 6. So that means here we've got x is going to be 6 times root 3. And that was pretty easy. And this one's going to be 6 times 1. No, that's just 6. And there we go. We've got our two answers. We want them as exact values, and there they are. Not much else we could do. Pretty easy. This one's a little bit trickier. We've got to use a little bit of logic for it. So let's see. Well, this 45-45 triangle here, what we know about the 45-45 triangle, it is an isosceles triangle because these two angles are the same. So this side and this side are the same. Therefore, 16, or so this B1 is 16 because they have to be the same length. Isosceles triangle. Now the other one here is a little bit trickier. I wouldn't say it's actually that much trickier at all. I would have to compare it to that 30-60 triangle we had before, right? So this one here, I'm just going to draw it out this way this time. So there's that. The 60 degrees is up here in that top corner. Across from the 30 was a 1. Adjacent that's root 3, and the hypotenuse is 2. So if I'm looking at this picture, it looks, how do I go from a 1 to a 16? Well, it looks like a times by 16. That means that's what I got to do to all the other sides. I got to times that by 16, so this ends up being 16 root 3. B here is just the addition of those two sides. All right. So now we want to find, from the diagram, h is going to be 16, right? Yeah. That's just height, straight up and down, it's 16. But my b is those two pieces. So if I go for the area here, I'm going to go 1/2 times, I'm just going to reorder them. I'm going to put the 16 first. We'll see why in a second, and then I'll put my base here, 16. Okay, I want to find the exact value. I want to find the simplified version, so I'm not going to have all these brackets. So remember, when you multiply things, you pick two things, you get an answer. So 1/2 at 16 is 8, so I'll just get that. So I'll multiply the first two things together. And then you take another two things, you find an answer. So I'm going to multiply this 8 into the brackets here. If I remember my radical rules, when I multiply things, you only multiply things that have the same exponent. So I'm going to multiply the 8 and the 16 together, get 128. And then the 8 and the 16 together, get 128. The root 3, I don't get to multiply it because it has a different exponent, right? Otherwise, I would just multiply them together before, and then would have had a single answer. That's all we do. There we go. That's not a bad answer. Oh man, there's a lot of questions I gave on this sheet. Okay. Let's see what we have here. Find the indicated angle or side. So this one I want to find angle B here. So that's what I'm looking for. I'll put a little question mark there. All right. So first of all, I got to identify, can we use the sine law or the cosine law, right? Because we have this kind of pairing here, we have this angle and the side across from it, I'm allowed to use the sine law. Right? If I didn't have that pair or any pairs whatsoever, I can't use the sine law. Right? So it looks like on this one over here, I also have that same situation. I got the 25 and across from it I got the 20. Because I have that, I'm allowed to use the sine law as well. Right? Cool. So let's set up the sine law. So we're trying to find B, angle B. So I'm going to put the angle on the top here with the sine. So sine B over B. Oh, looks like, oh, good. I have B already. If I didn't have B, I would probably have to find C and then do some weird things about that. Then I'm going to go sine 38 over 10.3 here, because those are the ones that go with each other. Or it's sine B over B, A over A, or C over C. So these guys correspond to each other. All right, then we're just going to cross multiply, divide here. So what I'm going to get here is I'm going to get sine B, because that's what I'm solving for. I'm just kind of multiplying up to the other side there. So 5.4 times sine 38 divided by 10, oops, 10.3. I'm going to get decimal here. Da, 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 da. And then what you got to do is you got to take the inverse of sine on both sides. So I'm going to go sine inverse, my answer. It doesn't specify in here, there's no decimals. So I'm just going to go 19 degrees here. Perfect. There we go. All right, so this one here, we want to find side B. So that's across from here. So that's what we're looking for, this one here. That's side B, right? But we need to know angle B first. So to find out what angle B is, because we have two angles, and whenever you have two angles, just find the third right away, right? So we're going to go 180 minus 25 minus 35. And that's going to give me angle B, which I'm going to need here. So 180 minus 25 minus 35, get 120. So remember the sine law, you can only find an angle less than 20, but you're allowed to use an angle, or sorry, less than 20, what am I talking about? Less than 90, but you're only allowed to use an angle, or, yeah, you can only find an angle less than 90, but you can use an angle, whatever angle you want. So this 120 is fine. I'm trying to find B, so I'm going to go B over sine 120. And over here, I'm going to use C, so I'm going to go 100 over sine 25. All right, I'm going to cross multiply, I'm going to divide. I don't do anything fancy because we're solving for b here. Here we solve for sine b, so I had to do an extra step. But here, after I cross multiply divide, we should have b. Sine 120 times 100 divided by sine 25. So we have 205. Perfect. Bigger the angle, the bigger the side. That's a pretty big side. Now I determine b to 1 decimal place here. So b, where's b? Oh, this b up here. Oh, we don't have a pair. So I don't have angle C. I don't have angle A. Okay, so no sine law. So this has to be the cosine law. I'm trying to find b now. So I'm going to go b squared. So remember in the cosine law, it says c squared. But remember, c is just what you're trying to find in that law. Right? C is not angle C or side C. It's just the side you're trying to find. And the other two, A and B's in that formula, they're just the other two sides. And that's what we have here. We have the other two sides. So we have this one, you got this, so 100 squared, minus 2 times 50 times 100 times cos. And it says cos C. Remember, that's just the angle that corresponds to the side you're trying to find. So technically, this is angle B here. So 155. Sometimes that just confuses people. I don't know why. All right? So I just recommend punch everything in your calculator in one big step. So 50 squared plus 100 squared minus 2 times 50 times 100 times cos 155. Boop. We're going to get an answer. That's a big answer. 21,563. And there's a bunch of decimals there and change. But remember, this is b squared. It's like Pythagorean theorem. So we've got to take the square root of our answer. So that one makes more sense. It's the largest angle. So it's got to be the largest side. And we got 140 to 1 decimal place. 46.8. Cool. That wasn't too bad. I'm just going to put down here that we took the square root. Sweet. Determine the appropriate method to solve for these. Okay. Find an angle. Okay, because we have this pair, I'm going to use the sine law. Right? We have a pair. Okay. Don't have to actually do it, just the appropriate method. Oh, no pairs here. It's cosine law. Yep. Okay, no pairs. I should write that down somewhere here. No pairs. Okay, so what do we have here? We have to go, oh, we have a pair. Angle on a side, because I have that, I'm going to just use the sine law again. Okay, cool. Oh, we got a pair here. X and X. So we got to use the sine. So we only had to use one cosine law there. Now you could just use the one cosine law, that was it. Good, good. Yeah, so this one here, we're trying to find out how many triangles I can create. I'm not trying to solve them or anything. I just want to know how many triangles can I actually draw here. So most of the triangles they give you, or we're able to draw, but we're just trying to find how many. Because sometimes the numbers I give you, you just can't draw the triangle. You're like, sure, I could just throw all these numbers into a random triangle, but is that actually correct? If I were trying to draw it to scale, could it actually work? Or is it maybe there's multiple ways to kind of orient things to make things work? All right, so I'm just going to go kind of through the procedure that we do in the class. So first, I'm going to just draw an angle of 69 degrees here. All right, so this bottom line, yeah, I'm just going to go here. Yeah, I'm going to pick a different color. So this bottom line here, I just lightly put it in there. This bottom line, we don't know how long that line is. It could be like really long, right? Because they don't give us side C, but they do give us side B, and side B is this line here. So I'm just going to go right up to this top of this height that they give us here. And we're going to say that this is 69. I know it's not drawn to scale. You probably measured it, probably not 69 degrees, but that's okay. But we know that this line, if I were to kind of draw it to scale, this would be side B, because this down here is A. So this has to be B. And then I had to figure out, does A, side A, fit here? Does it fit in this little area? So what I'm going to have to do, I'm going to do a little bit of right angle trigonometry here. So I can use SOHCAHTOA. I'm going to use sine. It's 300 degrees. I'm going to find out this h here. This h is going to be the very important number. It tells me the minimum height of this triangle. It says here the minimum height of this triangle is 10.6 centimeters. That's the smallest distance from the top here. From the top here down is 10.6. This is my min distance. So now the problem is if I try to put 10.1 in there, 10.1 is going to stop short. I wouldn't be able to complete the triangle. I wouldn't be able to go down. If I try to take that little yellowish line there and kind of tilt it upwards to connect it, I just changed the angle. I'm not allowed to do that. I can't change that 69. It's going to have to go straight across there. So can't complete it. So no triangles. So I wouldn't even be able to solve it if I said solve this triangle, right? So you have to be very careful. Sometimes you have to think about, can you actually draw the triangle? In this case, I can't do it. So I'm going to type it all correctly in my calculator here. Let me just double check here. It's always good to double check. Yeah, just can't do it. All right, so we do the same thing here. I know I can't draw it to scale. I'll put my A down here. All right, I'll just make this blue again. Put my A down here. I'll put my 28 degrees in there. I'll put side B here. I'm going to have the option to put a side that I know I always put on the top here. Just makes it easier to kind of visualize what's happening. And then I'll pick a different color here. Side C, we don't know how long that line is. Now we want to double check, okay, what's the min height going to be? So I'm going to go sine 28. This seems promising because the angle is relatively small. Over opposite, over hypotenuse. There we go. This h is the height, if not the hypotenuse, right? So you have to be very careful. So h here, the minimum height, sine 28 times 6. Sine 28, 6. Let me double check. Sine 28 times 6. 2.82. You want to be kind of accurate on the length, just in case how close these numbers are. But it looks like A is going to fit. Like if I were to dangle it down, but the problem is I can't go straight down because it go too far. So you got to kind of lean it in and say, okay, that's going to have to see because it touches there and get 4. So at least I have one triangle. But then I'm thinking, could I draw this again? So there's one triangle where it kind of fits. And then if I were to do this again, let me just draw another tannish kind of line here, whatever colors. What do you call that kind of color? I don't know. Draw my 28 degrees again. There's 6. There's 28. But this time I can draw the line this way and touch there, and that would work. Right? Because here's my height. My height is still, the minimum height is 2.8. But now I can lean it inwards. It's not too big. It's not going to go too far over because it's less than that 6. So technically, I can draw these two triangles. Go down here. 2 triangles. I'm going to put a happy face there. Whatever my A in there. Okay, cool. All right, so now we're going to solve it. Most of the time, if I say solve a triangle, you should be able to draw it, actually. All the time I'm going to do it. In future courses, you may have to worry about that. Man, I have a lot of triangles here. I'm only 34 minutes in. Hopefully you guys are cruising along here, getting the right answers. I got B. So we got a side angle side here. So this is a doable triangle. So I should be able to draw this. Here's angle A. All right, angle A. Oh, that's definitely not angle A. Angle A is 110 degrees. Right? If I were to actually draw angle A a little bit more accurately. There's angle A right there, 110 degrees. I'll make this bottom one the 15 centimeters. And then I'll make this other side here 14 centimeters, because they have to be the other two sides. So if this is A down here, then these other two sides got to be B. Well, that's C actually. C, and this other side has to be B, which is the other two sides. And then the third side, I don't know how long it is, but I know it just has to connect from this dot to this dot. There's no other restrictions here. These other angles, they can be whatever they want as long as they make them work. And we essentially got to find it because we have to solve this triangle. So what do these angles have to be? What is this angle? What is this angle? That's this up here is C. This one here is B. And we've got to find side A. Okay, so starting off here, we have no, what do you call those? Pairs, right? There's no pairs. So we've got to use the cosine law to start off with. So let's find out A, because that's the only one. For the cosine law to work, we need an angle to go with it. So across from the A, there's the 110. And the other two sides, 14 squared plus 15 squared minus 2 times 14 times 15 times cos 110. All right. Plug it all in your calculator. Take the square root. Let's just do that first. 2 times 14 times 15 times cos 110. So before we take the square root, we get this number, 564.6, dot, 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 dot. And then I can take the square root of my answer and get A to be 23.7623. Now, you probably want to round that answer, so let's just say, it's in centimeters, it's 24. Let's say 24 centimeters. Okay, so now these decimals are really important, so I'm going to write a couple more here. 328. Okay. Because we're going to use those in that pairing now, because now we have a pair. We're going to use that answer to help us with the sine law. So now we have this pair here. I can write up the sine law. So the sine law, so my first step was to do this one. Now my second step is to use the sine law. We can find out B or C. Now, remember I always said find the shorter sides first, but A is the longest side, so it doesn't matter out of these two which is the best. It doesn't really matter. So let's just do C first. It's just good practice to do the short ones first. Okay, let's do B first. So I'm going to go sine B over B. And then I'm going to go over here. I'm going to go sine 110 over 23.762 dot, 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 dot. Okay? I love to use these decimals. Oh, what is B? How come I didn't put B in there? That's weird. B. I should probably put B in there. B is 14. I have that number. It's 14 centimeters. Okay, so now I can do a cross multiply divide here. And I can find out what sine B is. Okay, and that's going to be equal to 14 times sine 110 divided by this ugly decimal, and we're going to get 0.5536 with a bunch of decimals there. And remember, you take the sine inverse of both sides. Sine inverse, 34 degrees or so. 34 degrees. Okay, so now we have two angles. We can just find the third angle by going 180 minus 110 minus this 34 degrees. We can find out what angle C is. C minus that minus 110. There we go. 36 degrees. Slightly larger because C is slightly bigger angle. There we go. Perfect. Found all the pieces. All right, determine the side length x. I like it when you only have to find one thing. So it's much nicer. So we're looking for x here. Let me put that piece. Okay. So what is the side length there? Oh, we have a pair. Sweet. Well, I guess we have the pair. We can use the sine law. So you can go x over sine 41. And on the other side, 19.3 meters over sine 56. Cross multiply, divide. Don't even have to do anything weird and fancy, like take a sine inverse or anything. We just cross multiply and divide. So you go sine 41 times 19.3 divided by sine 56. You get 15 to 1 decimal place, so 15.3 meters. Might as well put the units in there, so it's good practice. Small the angle, small this side is a little bit smaller, because 41 is smaller than 56. That looks good. That was an easy, fast one. These ones you have to find one thing too. Oh, that's not too bad. You want to find side C here. A question mark right here, C question mark. We don't have any pairs, so we've got to use the cosine law. That's not too bad. It's nice that they already called it C. Remember, C is what you're just trying to find. Oh man, what did I just do? Saving. I have a save button? Well, now we gotta wait. I hit something. I hit a button on my little tablet writer thing. I don't know what that's about. Alright. There's a weird 4 there, so it's squared plus 9.2 squared minus 2 times 13.4 times 9.2 times cos 70 degrees. All right, we're going to get c squared, and then we're going to get c by taking the square root of both sides. I'm just going to prep myself beforehand. And 13 point, I type it all in my calculator, so I'm just taking my trusty calculator here. Type it all one big line. Okay, so we get 179.87 dot 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 dot. Take the square root. That doesn't specify. Well, there's one decimal in most of these answers, so let's go with that. 13.4. Weird. Seems weird, but maybe this is a nice isosceles triangle. Maybe it is. Or really close to being an isosceles triangle. I hope I didn't mess up. Oh, poop. I'll double check here. How can I mess up? Yeah, that's good. Okay. Go for it. Angle A. Oh, we're missing. We don't have any angles, no pairs. Okay, so we've got to use the cosine law again. So I'm going to set up here cos A. So remember, there's a cosine law to find the angle, so in which all the other sides just happen to be on here. But what's very important about this is that if you're trying to find this angle, even though that's not a pair, that's what I'm trying to find, that's 6. It's very important that that's the minus 6 over here, because this is minus c squared in the formula. But the c is what we're trying to find, so side c must be the side that corresponds to it. So that's very important that that is this one. But then the other two, I don't really care. They're just the other two sides. 10, 5, I like to put brackets around that bottom part there. Cos A, and then we're just going to take the inverse of that really fast. All right, nice easy decimal here, 0.89. Take this cos inverse. 27 degrees. Perfect. Looks relatively small in that picture. That's about right. Determine the measure of angle Q. Oh, so we're almost done here. Angle Q. So this one up here. Oh, we got a pair here. All right, so we can use the sine law. We'll go sine Q over Q. That's nice that we have that side that goes across on that one. And yeah, sine 80 over 8. It would be cool if that ended at 50 degrees, but probably not. Cross, multiply, divide. Gotta remember to take the inverse eventually. So I'm going to find sine Q first. So 5 times sine 80 divided by 8. So I get this decimal here, this ugly decimal. That's fine. There's a bunch of decimals here. Dot, 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 dot. And then I'm going to take the sine inverse. Sine inverse, my answer, 38 degrees? The nearest degree, yeah, so 38 degrees. Perfect. There we go. Hopefully that helps out. Good luck on the exam tomorrow. I'll be there, but good luck studying. How about that? Bye.